examples using your fingers. We use dots, we use fingers. Also, the other thing that we use are dominoes. Okay, these are dominoes. We can use dominoes to teach children to sabotage. Okay, as you keep using it straight away, they look at it, they can tell you this is 6, this is 5. They don't have to count 1, 2, 3. Okay, so that is sabotaging or group recognition. Okay, so we've finished 3. Yeah? So we've seen one-to-one correspondence, comparing, and sabotaging or group recognition. Now is conservation. Okay? Conservation is the principle that a given object or quantity remains the same, although its configuration or position changes, or it may be divided in certain ways. Okay? Children 5 years of age and under, they cannot conserve numbers. Okay? Some children come to school also cannot conserve numbers. Okay? They are not aware that moving objects in a set does not change the number of objects in a set. Okay? For them, the quantity of object varies and depends on the arrangement and configuration. Okay? They believe stretching a row of objects makes the row longer, and therefore the number of objects are more. If you have 6 objects, say if you have 6 chairs in one row, and you stretch the chairs, create more space between the chairs and ask them how many chairs, they will tell you is more than 6. If they tell you it's more than 6, it's many, that means they have not mastered conservation yet. Okay. Okay, this is Piaget's most popular conservation experimenter, where he put 6 balls in a row here, 6 pennies, 6 pennies in a row, 2 rows, and asked them under the original presentation, ask them how many pennies are there in row 1, they say 6. How many pennies are there in row 2? 6. Which row has more? And the children say same. Okay, but later the second row, he brought the pennies closer together and he asked them, now which row has more? And they said the first row. So children who can't tell you that the number is the same, they have not conserved numbers yet. Okay, so by the time children leave primary school, they must be able to conserve numbers. In fact, actually, when they come into primary school itself, they must be able to conserve numbers. So as a teacher, you must watch when the children are doing activities, whether they can conserve or cannot conserve. If they cannot conserve numbers, then you must give them extra work to help them to master conservation of numbers. Okay. Okay, so far okay?
Okay, madam.
Okay, today is a long session, by the way. A lot of concepts to cover today, okay? Okay, next we're going on to counting. Okay. Counting involves the process of determining the number of objects available, okay? Sometimes as teachers, we take counting for granted. When children come into primary school, we think they can count already, okay? So all these things, if you know all these principles, then you know what to watch out or look out for, okay? Okay, objects can be classified as discrete quantities, materials that can be counted one by one, like candies, marbles, toys. You can count 1, 2, 3. These are discrete quantities. And we have continuous quantities. That means they cannot be counted. For example, water in the glass or someone's weight. These are continuous quantity. So when we do counting in class, we always use discrete quantities, okay? So there are 4 counting principles that the teacher must understand. We don't have to teach this to the students, okay? But the teacher must understand this, the 4 counting principles, okay? So the first counting principle is one-to-one correspondence, okay? You have already seen this earlier, okay? So you know that one-to-one correspondence is matching, okay? So each numbered object is given only one number name. Number name here means 1, 2, 3, 4. These are all number names. So each object is only given one name. So the first object, you call it, you touch it and you say 1. Second object, you touch it and you say 2. Third object, touch or point at it and say 3. Fourth object, you point at it and say 4. Okay? So each object only has one number name. When you point or touch and say the number name, then you are doing one-to-one correspondence. So when we teach the child to count first, we must ask them to point at the object or touch the object and say 1. Point the next object, touch it and say 2. You cannot point the same object and say 2 again, okay? Because it's 1-to-1 correspondence. So we have to do this activity first. Give them concrete objects to count and watch how they're counting, okay? They must touch, okay? In the initial stages, when we teach counting, when the child touches the object, they must move the object away. You touch 1, move it away. Say 1, move it away. Touch the second object, say 2, move it away. Touch the third object, say 3, and move it away. Okay, so they know which they have counted and which they haven't counted. Okay, that is the first principle. Second principle of counting is the stable order principle. The list of number names must be used in the stable order each time the objects are counted. That means when you're counting objects, you always start from 1, 2, 3, 4, 5, 6. It must be in the order. Okay, the order of the number names are fixed, stable order. You must count 1, 2, 3, 4, 5, 6. You cannot count 1, 2, 3, 5, 6, 4. Cannot. Okay, so that is called the stable order principle. The third principle is order irrelevance principle. Order irrelevance principle is the order of the objects counted is not important, but the stable order must be observed. But the order of counting the objects is not important. For the first group, we can see that there are 5 objects. We count 1, 2, 3, 4, 5. No problem. Okay, we are counting according to stable order, and we're counting the objects according to the order. Second group, we are counting from the back. Okay, it doesn't matter. We can start from the back, but we are still counting using the number names in order 1, 2, 3, 4, 5. The third picture here at the bottom here, we are counting from the center. We're starting number 1 at the center, and then we move right, 2, 3. Then we come back to the front and say 4, 5. It is okay. We are not counting the objects in order, but when we count, we are saying 1, 2, 3, 4, 5. Okay, so the number name is in stable order, but we're not counting in order, so it is okay. You can count any object first. You can start from anywhere to count, but you must say the number names in order. Okay, this is the fourth principle, cardinality principle. Cardinality principle answers the question, how many? The name of the last number mentioned gives the sum of all objects. For example, if we asked, how many apples are there? So the child starts counting 1, 2, 3, 4, 5. So the last number name that you hear is 5. So that means there are 5 objects. That is the cardinality principle. The name of the last number gives the total sum of all objects. Okay, so there are 4 principles of counting. Okay. Okay, now we move on to the counting stages. Okay, children come, there are 3 counting stages. There are 3 levels of counting: rote counting, point counting, and rational counting. Children, when they come to school, some of them are at different stages. Okay, we want to bring all of them to rational counting. We want all of them to become rational counters. Okay, even in the first year, they must become rational counters already. Okay, okay, what is rote counting? Rote counters are children who know the name of the number. Okay, and the actual sequence up to about 10. They know how to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But they cannot match the object with the name of the number 1 to 1. That means they haven't mastered 1 to 1 correspondence. And they will continue counting until, in their opinion, all objects have been counted. Sometimes there are only 6 objects. Then you ask them to count, they will count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, maybe they think finish, and then they say, okay, finish. 13. Okay, so they are rote counters. Okay, for example, the first row of object here, there are 9 objects here, but the child start counting 1, 2, pointing one object and saying 1, pointing to the second object and saying 2, pointing to the third object and saying 3 until the end. But the number names are not in order: 1, 2, 3, 5, 9, 10. Okay, so that means this child can can do matching, one-to-one matching, but does not follow the stable order principle. Okay, the second example, the child follows the stable order principle: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, can follow the stable order principle but cannot do one-to-one matching. Child is counting, saying the number names too fast. Okay, so when point a number 1 and say 1, by the time reach the second object already said the number name 3. Okay, so cannot match 1 to 1. The third figure, the child cannot match 1 to 1 also. Okay, is pointing, this time the child is pointing too fast and counting, saying the name slowly, so he's not matching 1 to 1. So when you see all these kinds of examples, you know that the child is a rote counter. Okay, when you ask the child to count and they cannot reach at the right number, then there's a problem lah. Either they are doing rote counting or point counting. Okay, counting, the name of the number is correctly pronounced while pointing to the object in sequence. Okay, the child who's doing point counting will say the name of the number starting with 1 and point to a different object each time they say the name of the number. That means this child has mastered one-to-one matching. But when you ask the child how many there is, then they start counting all over again. They can point correctly and they can say the number name correctly. Say if there's 6 objects, they will tell you point first one 1, check point second one 2, 3, 4, 5, 6. When you ask them how many, they start counting again. They don't know, they cannot tell you how many. Okay, so that means they are better than the rote counters, just that they cannot understand the cardinality principle yet. Okay, so rational counters. Okay, rational counters, these are children who count rationally. They're able to express the number of objects counted. Okay, they have mastered all the 4 principles of counting. Okay, once children have mastered counting skills up to 10 or 20, then you can teach them more sophisticated counting strategies. Okay, so all children must become rational counters. Okay, so it is the teacher's duty to observe the children in class when they are counting and to see at which level they are. If you notice that they are rote counters or point counters, then you must bring them to rational counters. Okay, and then only they can proceed with learning more sophisticated counting strategies. Okay. Okay, let's look at 3 different types of counting strategies. When we want to count, okay, these are the strategies that we use. Counting on. The starting point is flexible. Counting on, you can start from number 1 or you can start from any number. Okay, children can start from any number and start counting. For example, they can start from 6 and count 7, 8, 9, or they can start from 9 and count 10, 11, or they can start from 34 and count 35, 36, 37. Okay, so counting on is a very good strategy for doing addition. So that's why they must learn counting on, because they will use this when they want to learn addition in the beginning stages. Okay, even we use counting on all the time in daily life. Okay, counting back is a subtraction strategy. Okay, for example, Bobby has 22 rabbits. If 3 are missing, how many are left? How do children solve this problem? Many of them count backwards. 22 rabbits, 3 missing. So 21, 20, 19. Okay, strategies are necessary to teach the operation. These strategies are necessary to teach the operation of subtraction. So counting on and counting back are 2 important strategies. Counting on is very important for addition. Counting back is very important for subtraction. So these strategies must be taught in class. Okay, this is already in the DSKP, so they have to teach. Skip counting. Skip counting is another very important strategy. Sir. Children can count in twos, fives, tens, and so on. Okay. The starting point and direction of counting are flexible. You can count forward or you can count backward. Skip counting prepares children for multiplication and division. So counting on prepares children for addition. Counting back prepares children for subtraction. Skip counting prepares children for multiplication and division. Okay. So benchmarks for counting. Okay. When children are at the age of 2 and 3, they must know how to count at least until 3. At age 4, they must know how to count from 1 to 10, and from back is from 5. Age 5, they must know how to count at least from 1 to 20 and back from 10. Age 6, 1 to 100, and must know how to count back from 20. So most children who enter year 1 in primary school, they must know how to count already from 1 to 100. Okay. But of course, as a teacher, you must always check this, whether all children can. If they cannot do, you have to teach them, okay? Hundreds chart is a good model for teaching counting, okay? This is called a hundreds chart. It's a very versatile teaching aid that we can use to teach counting. Okay, let's just look at the hundreds chart here. Okay, this is called a hundreds chart. We can use this to do counting. Okay, supposing we want to teach counting on, we can start at number 1 and we say count on. So 1 2, count on in ones, count 1 2 3 4 5 6 and so on. Or we can say count on from 25, count on. So 25, 26, 27, 28. Okay, count on 5 from 44. That means 44 5. 1 2 3 4 5. So 45, 46, 47, 48, 49. So when we want to teach 44 plus, okay, we use the on strategy. Start from 44. Start 44, you count on 5. 1 2 3. Okay, so you get 49. So this we have used the count strategy. Okay, so if we want backwards, we count 63, 63, 23. Okay? From 9, count on in tens. This is skip counting already. Yeah? When we count on in more than multiples of 1, then it is skip counting. See, from 9, we want to skip count in tens. Okay, so 9, 19, 29, 39, 49, 59, 69, 79. So children can see patterns already when they count. From 1, count on in 11. So 1, 12, 23, 34, 45, 56. Okay, in this way, children can see patterns. 5, count on or skip count in 5. Begin from 5, count on in 5s. For 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, you can even color or close one box and ask them what is the, if you count on from 5, what is the number here. So they will start 15, 25, 35, 45, 55, and they must tell you what's the number here. Okay, so this is a very good teaching aid to teach counting, counting on, counting back, and skip counting. Okay, say you have this much of money. Okay, say you have a 50 cents here and a 20 cent, 10 cent, 1 cent, 1 cent. Okay, so say I counted this money. Okay, I count this as 50 cent. I start from 50. Okay, I start from 50, then I say another 20 is 70, another 10 is 80, another 1 is 81, 82. So what strategy am I using here? If I count like this, what strategy am I using here? Anyone? Because I'm starting from 50, then I count to 70, 50, another 20, 70, 70, another 10, 80, 80, another one, 81, 81, another one, 82. So this strategy is counting on. Okay, this is a counting on strategy. Counting on, we normally start from the biggest number, and from there we count on, because we can see the biggest number. Okay, so from there we count on. So that means this is counting on strategy. So counting on strategy is a very useful strategy for addition. Okay, so we finished with counting. Okay, now we move on to cardinal and ordinal numbers. Cardinal, ordinal, and nominal numbers. Okay, do you have any idea what is cardinal and ordinal numbers? Yes? Okay, maybe you have, just that you don't know the names. Cardinal and ordinal numbers. Cardinal gives us the quantity of the object. The cardinal number answers the question how many, not how much. How many? Example, 2 or 4 or 6, 10, or any number. Okay. When you ask the question how many, the answer that you get is a cardinal number. Okay. Ordinal numbers give the position of the object. Ordinal numbers emphasize arranging objects in order. It answers the question which one. Okay, example, the 6th, 7th, 16th, that is ordinal numbers. Ordinal numbers focus on the position of the object, first, second, third, and so on. Okay, and then we have nominal numbers. Nominal number is a numeral with no information, but it's just for identification or classification. Anyone can give me an example of nominal numbers? The number doesn't mean anything. It's just to identify something.
0.
Again? Again? Who's that? Give me an example.
0.
0. Um, 0. 0 is actually a cardinal number. When we say 0 is a cardinal number, nominal means you must tell me where you see this number, nominal number. See, this nominal number is, it doesn't show quantity or position, it just shows identity. So what kind of examples are nominal numbers? It's just a name of something, but the name is in numbers instead of say color or something. We're giving it number. Say sometimes you buy paint. The paint has numbers. Say 312. 312 means deep maroon. Okay. So the 312 is a number, that is nominal number. Okay. What are the examples of nominal number?
Jersey numbers.
Yes, jersey numbers, correct. Okay, because that number doesn't mean anything. It doesn't mean that number 3 is better than number 4. It just means that it's player number 3. Okay. Okay. Any others?
Color code.
Color code. If the color code is in numbers, okay. The other types of nominal numbers are your identification IC number. Okay, your IC number is just a number. It doesn't mean anything, right? It's just a set of numbers. That's nominal number. Your index number, Uncle Giliran, that is nominal number. Okay, your car number, telephone number, house number, all these are nominal numbers. Okay, they're just numbers to show identity. Okay, ordinal means position, cardinal is how many. How many. Okay, so this is how we can remember. Cardinal is for counting how many. Ordinal is for order, the position. Nominal means name. Okay, so this is how we remember the 3 different numbers. Cardinal is how many, ordinal is position, nominal is name. Okay, these are examples of cardinal numbers. 1, 2, 3, 4. All these are cardinal numbers. Okay, ordinal numbers will be first, second, third, fourth, fifth, sixth, seventh. These are all ordinal numbers. Okay, So when we teach this in class, and this is not the way to teach. How we of course we can give them all this and say this is cardinal, but we must do it through activities. Okay, say or you want to teach ordinal numbers. What can you do? What kind of activity can we do in class to teach ordinal numbers? It's just a simple activity. How do we want to teach them to say first, second?
Counting.
Counting, but when they count, they will say 1, 2, 3. But we want them to say first, second, third. How do we, what kind of activity?
Line up.
Yes, we can ask them to line up and we can say who's in the first position, second position. Huh? Good, okay. Okay, what, anything else? We can put all the students in a row and we can ask them at the back of the class and ask them to run to the front. Maybe not all the students, maybe group by group, because we don't want chaos in the classroom, right? So maybe group by group, we can ask them to run from the back to the front and see when they reach the first place, give them the label first, second, third, fourth, fifth. And then we can ask them to line up according to their numbers, ordinal numbers, okay? So these are the type of activities that we can use to introduce numbers. Counting will be good to introduce cardinal numbers, okay? Okay, these are examples of nominal numbers. Okay. Okay, let's look at this example. Can you identify the different types of numbers here? How many numbers are there here? How many numbers do you see here?
5.
5.
5, yes. First one. What kind of number is this?
Cardinal.
Ordinal.
Is it cardinal or is it ordinal?
Cardinal.
Cardinal.
Okay, I still hear someone saying ordinal, okay? Actually, it's cardinal because why is cardinal? We can ask the questions, how many residents? So when you ask how many residents, the answer is 600. It's a cardinal number. Second one, cardinal, ordinal, nominal?
Ordinal.
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 Ordinal, yes. Okay. Ordinal, which anniversary? The 100th anniversary, okay? Third one?
Cardinal.
Yes, cardinal. How many kilograms? 1,000 kilogram. Okay, so it's cardinal. Fourth,
Cardinal.
cardinal. Yes. How much? 400. Cardinal. Okay. In this case, we have to ask how much. Okay. Fifth, last number.
Ordinal.
Nominal.
Ordinal.
Yeah, I think it's ordinal. Because it is the fourth junction. We're going to count. First, we're going to pass the first junction, second junction, third junction, or fourth junction. Okay, so this is the ordinal number. Okay. Okay, if you answered all correctly, that's good. Okay. Okay. Okay, now we're moving on to reading and writing numbers. This one I won't teach so much because you've already done this in knowing numbers, in numbers and number structure. Okay. Okay. Say you have an example of this number. This number is written in the standard form. When you write it in numerals, it is called standard forms. When you write it in words, it is called word form. When you write it like this in expanded notation, you decompose the number. You're breaking it down into the place value. That means it's called expanded form. Children need to know how to write numbers in all three ways, okay? When we want to, how do we actually start to teach writing numbers in the classroom in year 1? In year 1, they learn how to write numbers, right? How do we teach them? Give them a worksheet and ask them to follow? How? How did you learn how to write numbers? Okay,
In
if you're-
paperwork,
How?
writing many times.
Writing many times. Okay. Okay. Is there anything else that we can do before that?
Following the dots at kiss.
Okay. Following the dots. Yes. Before that? Before they follow, of course, we know if you go to the bookshop, you will see lots of writing books where they just write the numbers following the dots. Huh? How else can we teach them writing of numbers, especially numbers 1 to 9? We must teach them how to write numbers 1 to 9 properly, okay? And of course, when we teach, we must teach the standard way first, because nowadays we have all kinds of fonts. So numbers that comes in different shapes and sizes. So we must teach the standard one first. So before we can teach them to follow the dots, maybe we should teach them to write in the air. Okay, you face your back to your students and you teach them, put your finger up in the air and you write the numbers and they follow you. Okay, and then we teach them how to write the numbers on their friend's bag. You know, they form the numbers on the friend's bag and the friend must guess what number is that. Okay, and then we give them clay, and ask them to form into numbers. Okay, when they form into numbers and they trace the numbers, or we use like something like a rope, a thick rope, we stick it on the cardboard and ask the student to trace the rope with their fingers. Okay, so they can trace the shape of the rope, they know the numbers. Or we can write numbers in the sand box. Okay, this is a very nice activity where you can either take the students outside or you bring a sand box into the classroom, just a box with sand inside, and ask them to write the numbers on the sand, practice writing. These are all pre-writing numbers activity, which are very interesting and fun activities which the students will like to do. Okay, and after that only you move on to the dots, ask them to follow the dots to write the numbers, and then finally write the actual number lah. So you see, when you want to teach something, it's not so simple as just writing like that. Okay, there are many steps that we have to follow if you really want to teach properly lah. When you teach like this, you can guarantee that the end result will be very good lah. Okay, so reading numbers is a reading. When we teach how to read numbers, we normally follow the place value chart. I've done this before with you already. Okay, say we want to read numbers. What do we call these? What do we call these ones, thousands, millions, and billions?
Place value.
This one we call place value. Ones, tens, hundreds, all these are place values, right? Yeah, the ones, sorry, correct, you're correct. That is place value. What do we call this? This one here. See, we have ones, tens, hundred, ones, tens, hundreds. So what do we call this? We did this in 3013. We call these periods. So when we always, when we have a number like this, say we have 4, 3, 6, 2, 9, 1, you want to read this number, we always divide this into threes, okay? And then only we start reading them. This is called periods. So how do you read this? Anybody want to try reading this number? Anybody want to try reading this number? Doesn't matter if you make a mistake. Simple number. I'm sure you know how to read this number. Anyone? Nicholas?
436,291.
Again?
436,291.
Okay. So there's an and here. Is there an end here?
I guess.
Yes, there is an end here. Okay, and sometimes you will see we read with an end here. Sometimes this end, if you don't read, also is okay. But usually it's better to to be uniform lah. Okay, so the end is usually between hundreds and tens. Okay, so this is 436,000. After the 6 you must say the period name. Okay, 436,291. Okay, so this is called a place value chart, as you already know. Okay, so to teach how to read and write numbers, we normally use a place value chart. From here also we teach them how to write in words. Okay, because they have their own convention. Like this number you have to write there 90-1. Okay, between the 10 and the ones there is a dash. Okay, so all the conventions of writing you must know. These conventions are all not in the DSKP. They don't tell you how to write this, so you have to go find the textbook and find out how to teach this. Okay, so reading and writing numbers must use a place value chart. Okay, another good teaching aid to use for place value is called this place value folding cards. Okay, we use these cards. We can make either 2-digit or 3-digit or 4-digit or 5-digit or 6-digit cards, and then we can fold it and open it. How we fold and open it is we want to teach that. We can say, for example, the card at the bottom here, we can read it as 7,534 ones, or we can say it is 753 tens and 4 ones. Okay, so there are many different ways of using this card and reading this card lah. So this later we will see how to do that. Okay, next we go on to rounding. This is the last concept, rounding. Okay, when we teach rounding, there are rules that we have to teach the student. Okay, so I'm sure you all know these rules already lah. Okay, and this is one of the good ways of teaching rounding lah. First, you tell them to underline the place being rounded, and then look at the number to the right. If it's 5 or bigger than the underlined number, you add 1. Okay, if it's lower, you keep it the same, and then change all the numbers to the right to 0. Okay, this is the last step that we will give them the rounding rules. Okay, so before that, you have to teach them a few other questions, a few other strategies to do rounding. Oh, okay. Before that, I want to do this activity with you. Okay, place value activity. Okay, you see the boxes here. The first number here is a 3-digit number. We want to make a 3-digit number. So I hope you have a piece of paper in front of you. You just make 3 dashes on your paper. Okay, so the goal of the for the first number, the goal is we want to make the biggest number. Understand, everyone? For the first round, we want to create the biggest number. So I'm going to give you 3 digits and you write the digit anywhere you want. But once you write it, you can't change it. Okay? So the goal is to create the biggest number. Do you understand?
Yes.
So do you have
madam.
in front of you?
Yes.
Paper, make 3 dashes like this or 3 boxes. Okay? So when I give you the first digit, you write anywhere you want. Okay? But remember, the goal is to make the biggest number. Okay? The first, what you can do in class is you can throw the dice. Okay? You throw the die and you say, okay, first number is 6. I have 2 dice here. Okay? First number is 6. Where do you want to put it? Do you want to put the first place, second place, or third place? But once you write it down, don't change it. Okay? Okay, first number is 6. Second number, 9. Third number, 7. Okay, so we have 3 digits here. So what should be the biggest number? Biggest number should be 9, 7, 6. Did you get that? Anybody got that? 976?
Yes.
You got? Okay, good. Okay, so that's first round. Okay, second round, second number. Now we are playing smallest number. Okay, now we are playing the smallest number. First number that I'm rolling here with my dice. Okay, first number is 5. Second number, 2. Third number, 4. Fourth number, 6. So what is the smallest number that we can make with these digits?
2, 4, 5, 6.
2, 4, 5, 6. Anybody got that?
Yes.
Okay. So this is called a place value activity. Okay. By playing this kind of games with students, we teach them how to understand place value. So as they keep playing, they know already where they must put the biggest number and to make a biggest number, and where they should put the biggest digit to make a smallest number. Okay, so it's a good activity lah. Okay, so we go back to the rounding. Yeah, sorry. Okay, to teach rounding, we have to, it's a very good idea to use number lines. Okay, so number lines really help the students to understand the rounding principles. Okay, so there are many things that we must teach them. The first thing that you have to teach them is to determine the midpoint between two multiples. Say you give them multiples here, you give them 40 and 50. We teach them how to determine the midline. So what is the midline here? What is the number at the midpoint?
45.
45, yes. So we start with small numbers in tens, then only we gradually go up. So what about this number? 500 to 600. What is the midpoint?
550.
550. What about this number? What is the midpoint?
325.
Yes, 325. So we need to teach the children to identify the midpoint between two multiples. Okay, this is very important before they can actually do rounding. Okay, once they've done that, then we give them a different kind, slightly different kind of exercise. Now we ask them to determine the multiples a number is between. Say, for example, we give them, this is 75, and we give them another number here, 72. Ask them to determine these two multiples. Okay, what are the two multiples? So now 75 is in between of which two multiples of 10? What's the number here on the left?
70.
70. On your right?
80.
80.
80. Okay, so this is not a very this is easy for you, okay, but it's not easy for the children. Okay, they need to think and understand it properly. Okay, I give you another one. Say this is 350. Here we have 371. So what two multiples are the number between?
300. 400.
300 and 400. Okay, so we continue with this kind of activity. At first, we give them the multiples, ask them to determine the midpoint. And then we give them the midpoint, ask them to determine the multiples until they have mastered all this. It's very, very important for them to know this for rounding. They don't know this, it's very hard to do. After that, only they can do any number. Say they want to round this number to the nearest 10. What do? They need to put this on the number line. So where will the number go? What are the two multiples here? What's the number on this side, on the left?
340,
340 here,
350,
350. What is the center number?
345,
345, and you know 347 is here. Why did you choose 340? Because I think I told you just now that we want to round up to the nearest tens. Okay, we want to round up to the nearest tens. So we want to round up to the nearest tens. So we have to start here from 340, not 300. Okay, so this is what the students need to know. When you give them a number, they need to know how to place it on the number line. When they placed it correctly on the number line, from here, they just follow the rules. Okay, and they can see clearly that 347 is closer to 350 than it is for 340. There are many activities that we can use to teach rounding. Rounding is a very important principle. Many children, when they go to secondary school, also cannot do rounding. Don't know. You know why? Because the teachers sometimes teach just follow the rule, and sometimes it's difficult to follow the rule. Okay, so they don't know. So you must teach it through various ways. Number line is one good way. Another way is to do it simulation in class, you know, by using steps, walking. You walk towards the number, you walk towards another person, and so on. Okay, so during teaching all these different ways, we can help the children to master rounding. Okay, rounding is very important skill for children to master, and many children don't do this because teachers don't teach them the right way. Okay, so hopefully one day you'll be teaching them the correct way. Yeah. Okay, so this is the last slide, I think. So rounding thinking questions. These are other activities that you can do when you're teaching rounding, okay? You can ask them to write, these are puzzles, okay? You can ask them to write a 2-digit number that rounds to 100 when rounding to the nearest 10. Number 1, what's your answer?
$97.
97, okay. Any other answer? 90?
99,
Again?
99,
99, correct.
98,
98, okay.
95, 96,
6,
96. What else? So how many numbers are there?
5,
Yes. So there are 5 possible answers. Huh? Okay. So these kind of things will make them think, because one person might just give one answer and then the other children might give different answers. And then they start to realize, you see, why there are so many answers. And then they look at the rules. Okay. And then they know, they learn more. Lah. Okay. Number 2, Connor has a 3-digit number written on an index card. The digits are 9, 2, and 6. When rounded to the nearest 100, his number is 700. What number is on Connor's card?